Dr. Najeem Laval får berätta mer om vindkraft.
Tack så mycket. Now I take this very briefly in English. This is an application example of how we can use cameras to measure parameters in the environment. For example, we want to very simply put monitor an environment in search for birds. Very simple. And this we can do already in the laboratory. It's very simple. You connect cameras to some computer, you get images, you process them, and you find the objects that you're interested in. Very simple. But then again, so here's some results. We have in the field with Vattenfall in Denmark. So we have 4 cameras, 2 of which you can see very easily. But then here inside, we also have 2 other cameras. And I will explain why we have this kind of organization. And from these 2 cameras, you can actually see that we get some images. So the turbine in one camera is the same turbine in the other cameras, but because they are sitting together, you can actually see that we are seeing the same thing from 2 different cameras that are very close by, 1 meter apart. So, like I mentioned, it's very simple. But then when you want to take your research from indoors to outdoor, it becomes complicated. So what then do we have to do? We have to analyze, for example, properties about the object, how big it is, how fast does it move. This kind of properties determines the kind of resolution of the camera we are going to use. So what is the frame rate and how big the camera we have to use, the lens that is going to be put on it. Okay, we are going to be in Sweden. Now we can look towards the north, so we avoid direct sunshine. But then again, you still have cloud and some dark areas, so we need a very good high dynamic range camera. We also have some other parameters that we have to analyze to make this simple project realistic outdoor. Otherwise, it's just a laboratory experiment that works, but then when you take it outdoor, it doesn't work. Okay, so to measure, here is the challenge. I don't know how visible it is, but here's the challenge. We want to monitor this turbine. We have some ditch around here, and what we can do then is that we can pull some cable between that, and in this radius, we have approximately 70 meters. So anywhere around here, we have the permission from the farmers to put our cameras, but it's not so easy. So then we can put our cameras here or somewhere around here, and that's what we planned at the end of the day. We put 2 cameras here, and you can see one is blue and the other one is red, and 2 other cameras here, blue and red. And if you are looking from one camera, this is the field of view that you see, and we can see that we can actually cover a whole turbine. But then there is a little bit of a challenge. Each of the cameras, and now we have times 4 of them, each of them is 13 megapixel, capturing data at 4 frames per second, and we have to, one way or the other, get the data in here in the turbine as quickly as possible. And to do that, we have to do with fiber network, fiber cables, and all the other extra challenges that you don't meet in usual cases. And this is what makes the project a little bit challenging. So when you want to measure, like Benny said, when you want to measure boats on the runway of an airport, it's very simple. You just put camera and you will see it. But then again, the camera is sitting approximately 2 kilometers away, and you want to see a boat approximately 4 centimeters. It's and you know, maybe you have an array of cameras to use, but then there are some strategical decisions to be made before we can actually make a very simple machine vision project an industrial reality. So that's what I have been working on, and that's what we have good data today, and we are going to do some more in this coming 2 weeks. We are going back to Denmark together with Vattenfall to do some more field tests. Thank you very much.